Hello friends, welcome to video lecture on engineering mechanics. In the today's session, we learn about the centroid. So let us start our discussion related with the centroid and center of gravity. So as we know, everybody is attracted to the center of earth by a force of attraction known as weight of the body. The weight being a force act through a point known as center of gravity of the body. Now let us start the discussion of center of gravity. So it is defined as a point through which the whole weight of the body is assumed to act. It is a term used for all actual physical bodies of any shape, any size or dimensions. For example, book, cupboard, human beings, dam, car, etc. So what's about the centroid? The significance of centroid is same as a center of gravity. It is a term used for center of gravity of all plane geometrical figures. For example, two-dimensional figures like triangle, rectangle, circle and trapezoid, or for one-dimensional figures like circular arc, straight lines, bend up wires, etc. Now, one thing clear about this one, center of gravity point comes into picture when we consider the three-dimension bodies or any physical object, okay? And when we consider the plane areas, then the centroid part comes into picture, okay? No doubt significance of centroid and center of gravity is almost the same. But if we consider the two-dimensional bodies, two-dimensional plane areas, then you need to consider the center of that is nothing but the centroid. And here in this case, if you consider the three-dimension bodies, then you need to consider the center of that is nothing but the center of gravity. Okay. Now here we'll discuss about the relation for the center of gravity. For that, consider the body of weight W. So in this way, consider the body whose weight is nothing but the W. And what's about this G indicate? G, X bar, Y bar are nothing but the centroid for this one, or center of gravity for this particular body we have considered. Now to get the information regarding centroid, okay. So here let us consider the body of weight W whose center of gravity is located at G, X bar, Y bar. So if the body is split in n parts, each part will have its elemental weight Wi acting through its center of gravity located at G, I, X, I, Y. So with this figure we can get the relation for that X bar and Y bar. Okay. Now here the individual weights, suppose here W1, here W2, W3, W4 up to ith term, that is Wi. Okay. Now this form a system of parallel forces. If you just say whatever the weight of this particular part, that will add in downward direction, this one adds in downward direction, this one in downward direction, this one in downward direction, means whatever the system form because of all the individual weights is nothing but the parallel force system. So what's about the resultant weight of the body would be then, so here in this case W is nothing but it is the addition of all the forces by considering its direction. Okay. So here the W also in the downward direction, so minus W equals to minus W1 minus W2. Okay. In this way, if you develop that relation, then minus towards the both the side means we can get the plus sign for the same. Okay. Here we can get W equals to W1 plus W2 plus W3 plus up to ith term. Okay. And you just see the nth term is the last one. So in this way we can get the information regarding the resultant weight or whole weight of this body by addition of small okay parts here. So summation of all these things, okay, we can indicate with the help of this relation, summation of Wi. Now to locate the point of application of resultant weight force W by using Varigna's theorem. Okay, so already we have seen the Varigna's theorem. For that, now focus on the this one first force, okay, whose magnitude here we have considered is nothing but the W1. For the next one, W2, W3, W4, W ith term, okay. If you just see the total weight of this one, we have indicated here with the help of this one W. Now what's about this one? These are nothing but the centroid of or center of gravity of individual parts. So in this case, to locate the point of application of resultant weight W using this one Varinger's theorem. So for that, if you just see here, if you take the moment of so individual weight here, so if you just say whatever the weight acts in the downward direction, if I take the moment of this weight about this y-axis, means we need this x distance, okay. So we can get the relation for that x. At the same time, if I take the moment of this same force about this one, this axis, that is x-axis, means we need this one, this distance. This distance means here we can get the distance in terms of y. So see, first of all, how to take the moment of individual weight about the any axis. Here we have considered the first one is nothing but the y-axis, so that we can get the information in terms about the x, okay. So x length, okay. So here what relation is written here, just here, taking a moment about a y-axis, moment of individual weights about the y-axis equals to moment of the total weight about the y-axis, okay. Now if you just consider this one W1, so what's about the distance of this W1, line of action of this W1 up to here, this distance, horizontal distance with us, that's why x1 is considered here. Now similar case with the next one, if I can take the moment of this particular weight about this axis, then this is the horizontal distance with us. So what we get here, W2 multiplied by x2. Similarly, case up to ith term, that is we can get in this way Wi multiplied by xy. This can be analyzed for n number of parts. So here we can write Wn multiplied by xn. So is equals to here the moment of total weight about the y-axis, means here moment of the resultant means here W indicate the resultant, okay, resultant of all the weights. So W multiplied by, so what's about the horizontal distance of this W with respect to y, here we can get the x bar. So W multiplied by x bar is written here, okay. Now what we get the relation, so this actually is shown the addition of all the moments, okay. So here we can write in this way, summation of Wi xi equals to W multiplied by x bar. If you equate this relation, what we get here, x bar equals to summation of Wi multiplied by xi divided by W. So in this way we can get the total relation for that x bar. So x bar equals to summation of Wi into xi divided by summation of Wi. Now this case we have analyzed for the x bar. Similar case we have just get by taking the moment of all the forces about the x-axis, okay, so that we can get the information regarding the y bar, okay. So for that, once again focus the individual weight of the parts. Here if I consider the W1, you have to take the moment of this W1 about this one, about x-axis, okay. Then we need this one, if you take the about the x-axis, means we need this one, this distance. So what's about this distance? This distance as far as concerned with this y-axis, this one is nothing but the y1. Similar case with the next one, y2. Then similar case with the next one, y3. In this way you have to consider the distances, okay. So what's about the weight? This weight we are assumed in terms of the force, okay. So here W1 multiplied by y1 will come. So W1 multiplied by y1. Similar case with the next one, W2 multiplied by y2 plus up to ith term we can just say Wi multiplied by yi, and if I consider the total number of parts, then Wn multiplied by yn equals to here the moment of result force about the this one, moment of the result force about the same point, means here you have to take the moment of this one W about this one x-axis. So for that you need to consider the y bar distance, okay. So in this way you can write this relation W multiplied by y bar in this way, okay. Now what we get here, y bar equals to summation of Wi yi divided by W equals to summation of Wi multiplied by yi divided by summation of Wi. In this way you can get the relation. Now if you just observe this relation number 1 and relation number 2, using the relation this one A and B, the center of gravity G of the body having coordinates x bar and y bar can be located. Okay. Now, what's about the relation for the centroid? Centroid means here we can get the relation for the plane areas. Okay. So in this case, we know the weight, the relation between the weight and mass. So weight is nothing but the W. Yeah, W equals to mg. Okay. So weight is nothing but here mass multiplied by g. So what's about the mass? What's about the basic definition for the density? Density is nothing but the mass per unit volume. Means we can get the mass is nothing but it is the product of density and volume. So density multiplied by volume equals multiplied by g. So density multiplied by, so what volume of that particular part we can get in this way, area multiplied by its thickness. So multiplied by g. So W is nothing but the rho later we are considered for the density. Rho multiplied by area we can get in terms of A multiplied by T. Okay, as the thickness of this one we are considered as T. Area we are considered as A. G indicate the gravitational acceleration. Okay, now we can just write this in this way, W equals to rho T multiplied by G. Just only this one area is written separate. So for the uniform bodies, that is of the same density and thickness throughout the body, we get this relation. So x bar already we have written here, x bar equals to summation of Wi multiplied by this one xi divided by summation of Wi. Now just here, what's about the meaning of this one W we can get with the help of this relation. So this relation already in front of you. Okay, so replace that summation of Wi by this term, that is rho multiplied by T multiplied by G multiplied by Ai. As the summation of that Wi is written, means here we can just give the suffix for this one as Ai. So what's about the next term? So this xi will remain as it is. You have to replace that summation of Wi by this term, this relation. Okay, so in this way you can get the relation divided by summation of Wi is there. So write this relation here. So this term and this term get cancelled. So what do we get here? Summation of Ai xi divided by summation of Ai. Similarly, we can get the relation for the yi. Summation of, just substitute the value of this one, Wi here. Okay, so that we can get this relation for the y bar also. So for that we can get in this way, y bar equals to summation of rho multiplied by T multiplied by G multiplied by this one Ai yi divided by summation of rho T G multiplied by Ai. This term and this term get cancelled. So what's about the remaining one? X bar equals to summation of Ai yi summation divided by summation of Ai. So in this way we can get the relation for the location of centroid, okay, for the plane areas. Now centroid G having coordinates x bar and y bar of the plane area can be located with the help of these two relations. Now what's about the axis of symmetry? For that, if you just see this one, this object is symmetrical about both the axes, that is along the x-axis as well as along the y-axis. Then its centroid will lies at the intersection of both the axes. If you just see the next case, now this object is symmetrical, or this one plane area is symmetrical about the x-axis, means here the centroid will lies on that particular axis. Now if you just see here the third case, here in this case the axis of symmetry is shown here, means this particular plane area is symmetrical about the y-axis, means the centroid will lies about the y-axis. Okay, this is the case of axis of symmetry. Okay, now next one is nothing but the centroid of regular plane areas. So one table is given. In that table all the information regarding the area and centroid of the particular plane areas is given. We can just take the ready-made values of the same and we can do the analysis for the various shapes. Now just here, what's about that tabular information with us? So in this case, so first one is given as a rectangle. So in this way rectangle is given. So as per our previous discussion, whatever the axis of symmetry, here is the axis of symmetry given, here is the axis of symmetry is given, means here we can just get the location for that centroid. Now What's about the area for the rectangle? We know the simple one, b multiplied by d. So what's about the x bar and y bar? Now for that it is very important to concentrate on the position of axis. So x-axis is here, y-axis is here. Okay. So in this case, what's about this one? What's about the location of this J with respect to this one y-axis? So here we can get that distance. So what's about the total base length is given? B is base length with us, and D is nothing but the height of this one. Height of this side given. Okay. So what's about half of this one? Half of this one is nothing but the B by 2. What's about the half of the total height? We can get the D by 2. So in this way, we can get the coordinates of this G point. Coordinates, we know the coordinates we can get with the help of that origin point. So here is the origin point. So this actually line indicate the x-axis, this line indicate the y-axis. So here we can get the origin. Okay, with respect to this origin, once we get the x bar and y bar value, that is coordinates of this point, our task is over. Okay. So next one is nothing but the case of right angle triangle. Okay. So in this case, what's about this one? This indicate the area of the triangle, half multiplied by base multiplied by height. So height we have considered in terms of h, base we have considered in terms of b. Okay. So area we can get in this way, 1/2 b multiplied by h. So what's about the next one? So b by 3. So b by 3 is nothing but this distance. This distance. Base length with us is nothing but b by 3. So it is not necessary to go in depth how this b by 3 and h by 3 is written. For that separate derivations are there. But as far as concerned with our syllabus, just take this one centroid x bar and y bar values as it is. Okay. So here b by 3 with us and h by 3 with us in case of the right angle triangle. So this distance indicate with respect to face end is nothing but the b by 3, and here we can get this h by 3 distance. Here we can get the tail end, here we can get the face end. Okay. Now in case of any triangle, so triangle is given like this one. So what's about this indicate? So axis, location of the axis plays an important role to get the information regarding the x bar and y bar, means the coordinates of that centroid. So in this case, if you just see here, x bar, this indicate the y, this indicate the x. So here in this case, what's about the area of the triangle? Area of the triangle we can get 1/2 base multiplied by height. So already the name is given here. Area. Okay, this column indicate the area, this column indicate the x bar and y bar. Okay. So if you just see here, whatever the position of axis shown here, that must be passes through this one. So that you can here say the value for the x bar dash or 0. Okay. So in this case, depends upon the location of this y and x, we can decide this one x bar and y bar. So what's about the y bar? Y bar in this case, this is the vertical distance with us. Y bar we can get in terms of h by 3. Okay. Now semicircle. In case of semicircle, we know the area of the circle pi r square by 2. We know for the complete circle the area is nothing but the pi r square. Okay. So divided by 2, we can get the area for the semicircle. Same case with the next one, for the quarter circle we can get the pi r square by 4. So what's about the x bar and y bar? For that, see the coordinates of this G point. So here we can get the y axis and here we can get the x axis. So by considering this one, we can get here as the origin. With respect to this origin, decide the coordinates of this one G point. So for that, if you just see here, we can get the x coordinate as 0 and here y coordinate with us y bar equals to 4r divided by 3 pi. Right now just remember this formulas as it is, 4r divided by 3 pi. Now what's about the next one? Quarter circle. In case of quarter circle, what's about the area? Pi r square by 4. What's about the next one? X bar we can get in this way, x bar 4r divided by 3 pi, and here we can get the 4r divided by 3 pi. 3 pi height of this one we can get in this way. So same actually written here. So always remember, with respect to nearer to this actually origin, you have to show this values, because the mass of this one, as this one is actually a plane area we have considered. If we consider the 3-dimensional object, then the mass is concentrated near of that origin point. So this distance with us, x bar equals to 4r divided by 3 pi and y bar equals to 3r divided by sorry, 4r divided by 3 pi. Now what's about the next one? This is the next case, sector. So in case of sector, whatever the angle subtended by that particular small area of that small length of that circle, in this way, circular part. So whatever the angle subtended by this one with respect to any axis, here the axis of symmetry is lies on the x-axis, means here we get the information regarding that coordinates, or centroid will lies on that x-axis, okay, in this way. So what's about here the axis, x y bar is nothing but the 0 here, as the axis of symmetry is shown here on the x-axis, means here we can get the y bar equals to 0. And what's about the area of the same, r square into alpha. So alpha you should consider in terms of radian, okay. So if we multiply by that degree with the pi by 180, we can just convert that into radian, okay. So what's about the next one, 2r multiply by this one sine of alpha divided by 3 into alpha, okay. So this actually alpha must be in the radian. Now we'll see what is the procedure. Now what's about the procedure for the centroid of composite area? So let me first of all clear to you what's about the meaning of composite area. When we combine regular plane areas, okay, whatever the, if you just see this diagram in front of you, this diagram is nothing but the combination of 3 different plane areas. First one is nothing but here half circle or semicircle with us, then next one is nothing but the rectangle, next one is nothing but the triangle. If you combine this one in this way, then whatever the plane area we obtain, that plane area is nothing but the composite area. Means composite area is nothing but it is the combination of many regular plane areas. Now what's about the procedure to get the centroid of the composite area? For that, whatever the composite area given to you, so here x bar and y bar is shown. So my task is to locate or get the coordinates of this J point. For that, in the first step, so divide this composite area into plane regular shapes or areas. So here we can just here that actually shown by dotted line. If I just draw here dotted line, okay, so first one we can get the rectangle like this one, second one we can get in this way a semi-circle. So what's about the next one? Here we can get the right angle triangle. So once we have divided this composite area into plane area, then prepare the table like this one. So this consists of part, area, coordinates, then ai, xi, then ai, yi in this way. So what's about the first part? We have assumed our first plane area. This is nothing but the rectangle. So here just indicate G1. The coordinates of this G1 are nothing but here x1, y1. Okay, give the number 1 for this one. Similarly, the number 2 is given here. So what's about the coordinates of this point? Coordinates of this G2 point are nothing but here x2, y2. Similar case with the next one. So location of all this actually a centroid with respect to every area is over. Then get the coordinates, that is x1, y1. Then get the information regarding the product of this ai, xi and ai, yi. Okay, so here we can get the information with respect to first part, that is the rectangle. So here that's why written a1 x1 and here a1 y1. Similarly do the same things for semicircle. Get the information regarding the area, that is indicated here by a2. Then get the right here x2, y2. Then get this information. Okay, get this information. So from this tabular form, what do we get here? We can get the summation of all the areas. Here we can get the summation of ai, xi. At the same time we can get the summation of ai, yi. Now once actually this one, the composite area is divided into a small part, that actually step is over. Then mark the centroid of every individual portion. That part also we have covered. Then prepare the table, tabular form is okay over. Then addition of all this area, we can get the summation of AI. At the same time, you can get the summation of AI xi. Then in the next step, you can get the summation of AI yi, in this way. Now once we get all these things, now use this formula. At last, the coordinates of the centroid of the composite figure are obtained by using this relation. Okay, this is the relation with us. X bar equals to summation of AI xi divided by summation of AI, and we can get the y bar equals to summation of AI yi divided by summation of AI. Now we'll see the simple cases where you have to locate the centroid for that particular plane diagram. Now just let us consider the case of this one, case of a rectangle. Okay, so this actually diagram is the thing, but no any connection of this one with this. Okay, this one, this one, this one. So these diagrams are a separate one. Our task is to simple here get the information regarding the centroid of individual plane diagram. Okay, so here the rectangle is shown. The base length for this one 3 cm with us, height for this one with us 4 cm. My task is to locate the centroid. Okay, for that, if you get the coordinates of this G1 point, our task is over. So what's about the G1? G1 is the thing, but here we can get the horizontal distance of the same. So what's about this one? We can get the x1. So what's about this? This indicate this is nothing but the y1. So what's about the x1? See the base length of this one with us 3 cm. As we are just moving towards the negative side of x-axis as well as the negative side of this y-axis. So here is the origin. Origin point is here. Origin point is here. This indicates the x-axis. This indicates the y-axis. This is the positive side of the y-axis. This is the negative. Sorry, this is the positive side of the x-axis. At the same time, this is the negative side of the x-axis. This indicates the negative side of the y-axis. So with respect to this one, you can decide the coordinates. So what's about the x1? X1 equals to minus y the minus b by 2 is written. For this one, we are considered b is nothing but the base length. Okay. So here we can get the minus b by 2. Why the minus written? Because we are just moving towards the left side of that x-axis, moving towards the negative side of the x-axis. That's why the minus sign is given here. So minus b by 2 equals to minus 3 by 2. Minus 3 by 2 means here 3 length is given for the base side. Okay. So what's about this one? 3 by 2 equals to minus 1.5 centimeter. So at the same time, what's about the y1? Y1 is nothing but here total height with us 4. So for this one, we are considered as d by 2. So why the minus sign is given? Because we are moving below of this y-axis. Moving towards the negative side of that y-axis. So that's why the minus sign is given here. Minus d by 2 means here. What's about the length for this side? 4 by 2 is nothing but the minus 2 centimeter. So coordinates of the same can be written in this way. G1 equals to minus 1.5 comma minus 2 centimeter. This indicates the x coordinate, this indicates the y coordinate. Okay. Similarly, you can locate for the other one. Okay. So answer for the same actually in front of you in this way. Now focus on this one. We'll discuss about the one problem on the same topic. So find the coordinates of the centroid of the area as shown in figure. So in this figure, if you just say the shaded portion is given, this is nothing but the shaded portion. Dark gray portion shows here the shaded one. Okay. So my aim is to get the coordinates of that shaded portion. Okay. Now if you just say this problem given. So in this problem, so what's about this one? Semicircle with us, at the same time quarter circle with us. Okay. Now as per our earlier discussion regarding the steps. So what's about the first one? You have to just divide this one composite area into plane area. So if you just see here, I'll consider this one. This is nothing but the quarter circle. Quarter circle is here. So what's about the diagram? Same diagram we have drawn here. Just locate its centroid. So radius for the same with us 20 centimeter. According to that, just draw this diagram. So locate this one G1. So once we show that G1, so what's about this indicate? This is nothing but the x1. At the same time, this indicate the y1. So the coordinates of this one are nothing but the x1 and y1 with us. So once this one x1 and y1 with respect to first part is located here. Now next thing, just think over it. So here this indicate the negative area. Why the negative area? Because the shaded portion is here. This indicate the gray portion. This one dark gray. This portion indicate the effective area where you have to find out the centroid for the same. Means you have to subtract this area. Okay. So before this one, just draw the separate diagram of every area like this one. So first one is here, next one is here, next one is here, in this way. Now, once actually this diagram for the first one, just step by step, draw the diagram for the first one. Now, what's about the name for this one given? Quarter circle A, O, B. This indicates the part number 1. So with respect to part number 1, do the calculations for the area. So what's about the area? Formula pi r square divided by 4. So in this way I can get the area for the same. So what's about this one? Do the calculation, get the value for the area. That is 314.16 centimeter square. What's about the A1 and Y1? Now with respect to this one, origin point is here. With respect to this origin point, so what's about this distance? So as per information given in the table, so what's about the x1 and this one y1? So x1 and y1 with us 4r divided by 3 pi. Okay, so same value given for this x1 as well as y1. So we can get the information regarding this x1 equals to y1 equals to 4r divided by 3 pi. So why this one r1, x1, y1 is written? So with respect to the first part, the suffix is given for this one as x1, y1. Similarly here r1, etc. So what's about the calculations for the same? So substitute the value for this one r here as 20 divided by 3 pi. Means what we get here? We can get the x1, y1 equals to 8.49 meter. Now similarly do the calculation for the semicircle. So semicircle is here. This indicates the semicircle. So with respect to the semicircle, draw the diagram, draw the separate diagram, locate its centroid. So centroid we can locate for that circle here. So what's about this indicate? This indicate the axis. So this indicate the x-axis, this indicate the y-axis. Now come back towards the problem given. So here this indicate the x-axis and this indicate the y-axis. So with respect to whatever the question diagram given, as it is you have to draw the diagram, separate diagrams, okay, by just splitting the original composite plane area into regular shapes. So in this way I can draw the diagram for the semicircle. Semicircle drawn here. Semicircle. So what's about the area of the semicircle? Pi r square divided by 2. In this way you can get the area. So what's about the calculations? Pi multiplied by 10 square divided by 2. What do we get here? 157.08 centimeter square. So get the information regarding the x2 and y2. So what's about the x2? Now see, here is the center of that circle, semicircle, and here is the origin point. So what's about this horizontal distance? Horizontal distance with us. In short, you have to find out the coordinates of this g2. So x2, y2. So what's about this x2? X2 is nothing but this distance. So what's about this x2? The radius of this one with us 10 centimeter. Means what we get here? X2 is nothing but the 10 centimeter. So what's about the y2? So as per ready-made formula given in the table, this indicates the 4r by 3 pi. So r2 suffix is given for the second part. Okay. So 4r2 by 3 pi. Substitute here the value of pi. Here r2 with us 10 centimeter. Do the calculation for the y2. So y2 we can get 4.244 centimeter. Okay. Now what's about the next part? Next part is, okay, here only two parts are there. First one is here and next one is here. Now what's about the centroid of the given shaded area? So for that we know the formula x bar equals to, so already we have seen that case with the help of that tabular method. But here whatever the formula written, this actually simple method. You have to just write the formula in a such way that we can write the positive value for the positive areas and negative for those area should be removed from the actual area. Okay, so here if I remove the semicircle from this total area, what do we get? We can get the area for this shaded portion. That's why the negative sign is given for this one. Now come back to that tabular method once again. Now as per our previous discussion, how can get this one? Summation of ai xi, summation of ai yi. So with the help of this one, whatever the individual product of the area and this one coordinates. So a1 x1, a2 x2, then a3 x3. Similar case with the y, that is a1 y1, a2 y2, a3 y3. So summation of all these terms, we can get the summation of ai xi. At the same time, what do we get here? Summation of ai yi. Now if you use this formula, this one, so summation of ai xi indicate the addition of all these things by considering the positive or negative area. Now same thing actually done here. a1 x1 minus a2 x2. Why the minus sign is given for this one? Even though this actually lies in first quadrant, this is the negative area. You should subtract this area, subtract this area from this one, so that you can get the area for this shaded portion only. I'll just show this shaded portion here. This shaded portion is here. Now what's about the formula written here? X bar equals to a1 x1 minus a2 x2 divided by a1 minus a2. Now the original formula is nothing but the summation of summation of ai xi divided by summation of only areas. Okay, so here a1 x1 is nothing but a1 x1, the product of this a1 x1. So a1 is here, x1 is here. So a1 with us 314.16 multiplied by this term, multiplied by 8.49. So same thing is written here. So what's about next one? Minus 157. What's about the a2? 157.08 multiplied by 10. Multiply by 10. So what's about the divided by this one? a1 with us 314.46. What's about the a2 is here 157.08. Substitute here all the values and do the calculation for the same. What do we get here? We can get the x bar equals to 6.98 centimeter. At the same time, do the calculations for this y bar. So y bar we know a1 y1 minus a2 y2. Why the minus sign is given? Because this is the area. You have to subtract this area from the this area. Okay, so that you can get the only area for the, so that only you can get the centroid for this shaded area. Okay, now in this way substitute the value for the here y bar, this one a1 y1 minus a2 y2 divided by a1 minus a2. So what's about the a1? So a1 already calculations for the a1 with us 314.16 multiplied by y1 with us y1 8.49 minus a2 with us 157.08 multiplied by y2 with us 4.224. Okay, same thing actually written here. What's about the a1 with us this value and a2 with us 157.08. Do the calculation, we can get the y bar equals to 12.74 mm. At the same time, we can get the coordinates of the centroid with respect to origin O, R. In this way, we can write the coordinates G into bracket 6.98. Okay, this indicates the x bar and this indicates the y bar 12.74 centimeter. So in this way, we can get the final diagram where we can get the answer for our x bar and y bar. So whatever the original main diagram is given, so as per as our first task, just split this original composite plane area into regular shapes and see which area should be considered and which area should be subtracted. Decide depends upon the geometry available in front of you. I think this problem cleared you. Thank you.